Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and a link in the info box once the video has rendered. But most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join the panel, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show, as sharing the show increases the chances of a more diverse panel by increasing the live audience. So please share the show. And one last time, if you are new to the channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by several guests. We have Ranty, Sleeping Warrior, and Darwin. So how are you doing, gentlemen? Good to have you all.
Good morning, good morning, good morning.
Good afternoon.
Good afternoon.
Okay, good afternoon.
Get all of them in there. Why not? Good evening, good night.
What?
Yeah. Now, Riley, if it would be morning for you, then you would be somewhere in Eastern Europe, I think.
So just before we start, well, we've got Ruhif already. That was quick on
Hello.
the mark. How you doing, Ruhif? Good to have you.
Waiting up for you, Nathan.
You've been waiting?
Yeah,
Poised.
12:15.
Well, Anthony's given us some hints as to your intentions today, so maybe you want to kick us off.
Okay. I want to talk about Ranty's Blackpool observation yesterday first.
Okay.
Does he still like there was a timestamp at about 1:15, 1 hour and 15 minutes where Nathan actually asked you, is it possible that we're looking at other mountains than the ones you've identified?
Yeah.
And you said absolutely not.
Yep.
So you still stand by that?
Yeah.
All right.
Oh, so this is contentious.
Well, it won't be in about 2 minutes.
Cool.
Fair enough. That's confidence.
Yeah. Just trying
How
to
you
share
doing,
my
Mark
screen 1
Doxy?
second.
Good to have you here. How you doing? You're on mute at the minute, Mark.
There we go. Can you present me, please, Nathan?
I can. Can I just make sure that's the real Mark? Can you just say a quick hello,
I
Mark?
feel a sniper coming on.
Might eject you, Mark, if you don't say hello.
Hello, gentlemen. Yes.
Oh,
it's
brilliant.
Ian.
Good to have you. Yeah, you're up now, Ruhif.
Oh, awesome. All right. Okay, so Ranty was over here, looking south. Oops. Going through the wind farms in this sort of area. And there are plenty of mountains closer to the coast than the ones you identified in the video yesterday around, was it Londonia, whatever it's called? Snowdonia, sorry. So there are plenty of mountains here that should be seen from Blackpool. So that one, Malfrey Uchuff, is 45.59 miles, and it's 1299 feet. I'll just get rid of that. Does someone have the...
Can I just
do you
check
want to do
that?
the Kirkhope?
Oh,
Could I
don't,
just
let him get to
check
the
that?
end. Come on.
Well, he just said it should be seen from Blackpool. I contest that.
Well, hang on. First and foremost, he's in the wrong location anyway. He's identifying different mountains that I was talking about.
Well, let's let him get to the end of his...
I'm
Let's
identifying
let him get to
closer
the end
mountains.
first before we start, criticising it.
Okay.
Let's just let him get to the end.
Yeah.
Yeah, sure.
Right. So this one here, get rid of the line marker. So 46.62 miles to Blackpool. Where is 46.62? I've given you a pretty nice observer height of 6 feet, and the refracted hidden is 1,075 feet for that. So that one should be seen. Carned Fid is 59.75 miles. Blackpool. Refracted hidden of 1825 feet. That's like way above the horizon. This one over here, Penny Clodiau, is 42.93 miles to Blackpool. 900 feet hidden, so that should be 500 feet above the horizon. We'll choose one at the back here. This, whatever that one's called. 53.64 miles to Blackpool. 1451 refracted hidden, so it should be 400 feet above the horizon. Basically, all of these mountains here are in your field of view, and they all should be seen from Blackpool. The end.
Fireball, hello.
Hello, how you doing? Can you say hello?
Is he sniping people?
I don't know. He's not said hello, so I've got rid of him. Yes, he is. Sod's law.
Sorry, Arwen got sniped.
I think all of the flat earthers that... No, Mark's still here. Maybe.
Okay.
I'll get the other guys back on, hopefully on Skype. But give me a second.
Yeah. Is Ranty still in the room?
No, Ranty's been sniped as well, but hopefully we'll get him back in a couple of seconds, then I'll add Arwen in.
All right. Oh, I'll wait.
Well, that didn't take too long, did it?
Yeah, that was quick. I just had Arwen in as well.
Yeah, I've only been going a minute.
Yeah, I know.
So we got sniped then, me, Arwen and Ranty.
I
Yeah.
think everyone did, I think.
No, I kicked him just before he could get
except
anybody
me.
out.
Ah, right, okay.
So we've still got Ruhif and Mark.
I guess
in the
my
hangout, which
wizardly
is good.
senses were correct.
Yeah.
Well, it was good timing
He came in with
in
a
one respect
fireball. That
because
was kind of fun.
Ruhif's just finished he's presented what he wanted to present.
Okay, cool. Can I respond?
Pushkan.
Yeah.
Okay. Let's see, that was yesterday's debate. I want that up. There's the video. Right. If you want to share me, Nathan.
Give me a second.
Wow, the guy is now literally, the sniper is literally in chat admitting that it was him.
Anyway, let's not worry about that. We've still got a show to run, so... Right, you're up, Ranty.
Okay, so here I am. This is my... I'll show you my location on Google Earth. You have to excuse all these lines because they are all over the place. Now, this is exactly where I was. And you'll see that I'm filming just past the South Pier. So I'm looking this direction, and then all the mountains that we're looking at are to this side on the video. Now, so when I come up and I show you the wind farms as well, these are interesting because we see the wind farms on the video. I'll just press play and I'll show you where they start. There we go. So there's the first wind farm there, where my cursor is. Then the next one, another one, another one, another one. So the wind farms start here, and then the mountains are on the left of that. There's no wind farms here. So when I go to Google Earth and I come in, you can see that this line that I've put in, that's the first wind farm there. So when I'm looking at it, I'm looking at these mountains that are to the left-hand side of these wind farms, which takes us to these rows, this row here, which I identified yesterday. Oh, it's not over here, it's not over there. You know, these were seen through the wind farms, but the ones I was talking about, if I go to the video again, are all to the left-hand side. You'll see it as I come out of the video.
Wow, nice. That almost looks like a crocodile.
That's exactly what I was just thinking.
But what is it really? Is it like
Anyway,
a
don't
front of a
hijack his
ship
point,
sticking
Arwen.
out,
Hold
or-
on, he's just getting to the crescendo of his point.
So here's the wind farms here. There's no wind farms to the left. Yeah, there's no wind farms here. So these mountains all have to be to the left of these wind farms here. So this is these mountains over here, which I'll say again, the distance is you shouldn't see any of these. Now, not only that, if you look at the size of the pier, for instance, go back to the start and I'll press play. Those piers are about 30 feet tall here. So I'm at six feet or so in height, let's say 6 above sea level. And when I pause this now, you can see that these mountains, tops of these mountains, are at least half the height of this pier, which means that I'm actually having to look up. So these are at 15 feet. If this was a 15-foot line here, I'm actually looking up towards the mountains. So I'm not looking down around the curve. I have to look up to these mountains to see them.
Of course you're looking up. I mean, you're at sea level.
Yeah, I'm looking up, but they're not going behind the curve. And how much of this mountain would you say is visible?
Hang on a sec. What do you mean, of course, you're looking up, you're at sea level?
I was just about to say that, so yeah.
Do you want to explain that comment?
Well, without refraction, but I mean, you're at sea level there, and the horizon's 3 miles away.
Yeah, but hang on. Can you just answer that question? What do you mean? Of course, you're looking up, you're at sea level. Do you realise that on a ball that you're always looking down?
Oh, yeah, of course.
So
but this goes to what I said the other day, is when Nathan goes, oh, Isle of Man is 600 feet below you or something. And I said, what if you're on top of Mount Everest at, however high it is, 9 Ks or whatever it is, and the next highest mountain is 8 Ks, the drop itself is irrelevant. You can still see it. You can still see the next mountain, 1,000 meters below you. You just have to look down a little bit.
Right, but you're at the beach, so that technically you're not looking up, right? You're looking down on a ball at all times.
Yeah, unless the mountain itself is actually higher, which I think some of them are. Let's have a look.
So therefore your last comment can be retracted, correct?
That you're looking up. If you're at sea level, you're pretty much looking up all the time, right? To see those mountains.
60 miles away?
Not on a ball.
You shouldn't see any of this. All this should be gone.
No,
all these mountain ranges
if
that we're
those
looking
mountains,
at, we shouldn't
if
see
those
any of
mountains
these.
are actually above 0 degrees, the horizon.
Yeah, but by how many
degrees?
degrees?
Let's establish that. No. Before we can go further, we need to establish exactly that, because that's a good point. Because what he's saying is, if the peak of the mountain, let's say that we've got a 600-foot drop beyond the curve, and the mountain is 2,000 feet. Well, you're going to have 1,400 feet that you are going to look up to. That's matter of fact on a ball or otherwise. So I agree with him, unless we don't, which is down to your ball maths. So unfortunately, it's time to go over to the ball maths, pick a mountain, and see whether or not we should be looking up at it or not.
Because according to if we're going at 40, if we're going at 40 miles,
most of the mountains that I pegged out on Google Earth were through the wind farms. So I've only got I've only really got one to the left, and that was that 1853-foot one, which should be seen. So I can either spend some time trying to find some more to the left, or we can just.
Are you happy, Ruhif, that they are left of the wind farms, or is that still in contention?
I think it's in contention because let me check. The wind farm. I'll concede that tentatively, I think, because the Burbo Bank is the closest one, and you'd have to be looking. You get awfully close to Southport, though, don't you? Oh, my elevation is not working in Google Earth tonight.
I mean, if Ranty picks one of these mountains, and can you just let us know whether or not you're happy for it to be that particular mountain?
The ones that I've already pegged out on Google Earth.
Well, no, because unless they're left of the wind farms.
Oh, I've only got one that's left.
I mean, if you've got one, that's good enough for me.
Yeah, I don't want to try and pronounce it. Cerny Brain. So CYRN-Y-Brain is 1853 feet. That should be seen.
Should be seen, no. But when you say it should be seen, let's talk about that.
Well, let's do the maths
How
on it. Let's just not beat around the bush. Let's just actually look at how much should be seen.
Let's get some coordinates. 1 sec. So 53 degrees, 2 minutes and 26 seconds north. 3 degrees, 10 seconds, 42. 3 degrees, 10 minutes, 42 seconds west.
You got a distance. I don't know. You may have said it, or I just didn't catch it.
Distance 53.64.
Did you catch that, Ranty?
Sorry, 53.6.
53.64.
1450 with refracted. Hidden 1707. The drop 1900. What's the height of the mountain itself?
What's the height of the mountain?
Is 1853.
150
Okay,
feet.
1853. So, do you think on the video that that's 100 foot of the mountain that we're only seeing?
Well,
because
I
if we're only
consider
seeing the
refraction
top
to
of
be
it,
part
say
of the
100
equation,
feet,
so I'd
then
see it as 400
the size
feet
of that
above.
house.
Well, hold on. No. Geographically, we're establishing whether or not we look up at it. So let's sod refraction for a moment. Geographically, is it above or below us? That's what we're trying to figure out.
1853. I would say no, actually. You'd be looking down.
Great.
But
So
refraction,
comment retracted.
Happy
would bring
days.
it up to be above.
So therefore, we can retract your previous comment then, yes?
Yeah.
But well, more importantly,
We're close to
forget the win.
horizontal.
Who cares? But don't you think that's interesting?
Yeah.
More importantly,
Yeah, but it's mathematically solvable. I mean, I think
Okay.
the what's the one?
How you doing,
One way
Flatmate?
to the
Can you
west.
hear us? Hold on, Flatmate, can you hear us?
I think Flatmate might be on his way out.
Yeah, he is. He's gone.
Gone. So the one way out to the west in the Snowdonia, is that what it's called?
Yeah.
Right to the wind farms is Snowdonia,
Yeah, so-
I think.
Oh, through them here.
Yeah, Carner Fid. Carner de Fid is 59.75 miles from Blackpool, and the drop is 2380 feet, but the mountain is 3425. So that is actually looking up.
Yeah, but we're not talking about these, though, are we? I was talking about the
No, I haven't
Nice
looked
mountains
for,
to the left of
I haven't looked for
the
ones
wind farm.
east of that line.
That, boys and girls, is technically known as a straw man.
No, don't be unreasonable. He's looked at it. He's just saying he's looked at it. That's it. That's fine.
But we agree we should
So am I still
see this
presenting?
1853 foot.
Hang on a minute.
Actually,
so
why
what's the
didn't you
contentious
see-
point then?
Say again?
What's the contentious point that you're not happy with?
Like I tentatively accepted that he was looking to the left of Burbo Bank, but now I'm wondering if he looks from that pier through what's the big power station there? Where is it?
Am I still
Gwinty
presenting, by the way?
Moor.
You are, yeah.
All right, cool. Because through the wind farms, just to the first part of the wind farms, the left part of the Burbo Bank, we have this other mountain range in the back, which is consistent with this point here. If I put a line in from there and bring it through to where I was, 70 miles away, and then I scroll in and I show you that this is parting through the wind farm, the first part of the wind farm.
I think you're
and I
pointing that through a
show you
different
the
wind farm.
video. And then when I zoom out, you'll see that the wind farms start here. So it's probably, I'd have to add up how many wind farms there are.
It's really hard to see, by the way.
I've got to be honest.
So-
I mean,
There is a
it's
mountain.
much more
There is a mountain to the
clear-cut
right
just-
that you should see comfortably and be well above the horizon.
Why not just stick with the ones left of the wind farms? Then there's no ambiguity.
Yeah,
Yeah,
because I
all
spent half
these.
an hour finding the
60
ones
miles
through the
away.
wind farms.
If I do the 60 miles to them, they should be 1,800 feet behind the curve with refracted. do the altitude of this. It's 1400, 1500, 1700, 1880, down to 14. Really drops off then down to 1000. So all this should be gone.
Yeah, I agree that we
That just
probably
begs
shouldn't
the
be able to see the
question.
ones at the back. Absolutely.
This begs the question: how much of the mountain are we actually seeing?
Well,
how much
I
of
was
this is visible?
hoping that you
Bearing
got
in
some more
mind that
footage to the right, like to the east, so to the right of that, because that one in the Snowdonia Mountains, should be
the
quite
one way over
clear,
here.
like well above the right.
Yeah, but this isn't Snowdonia. Snowdonia's way, way over here. You keep going back to Snowdonia. This is Snowdonia here. We're not talking
Yeah.
about that.
Do
We're
you
talking
agree that we
about
can see that, though, right?
these.
You agree that we can see that on a globe Earth, right?
Yeah, I can also see it in the video. But we're not
Okay,
talking
I didn't
about
see it.
what we can see and what we should be able to see. I'm talking about what we shouldn't be able to see, which is these.
Hmm.
And you can
I
see how
agree. I should be able
prominent
to see
they are.
those. I'm sure they're too far away.
You can see how prominent they are, though. And what I'm saying is that angular size. I wish somebody had the brains to work this out from our side. Probably have somewhere. But if I'm viewing this at around about 4 or 5 feet above sea level, and that's at 15 feet there, the angular size to that and the distances involved, we might be able to calculate what the height of those mountains, how much of the mountains we're seeing. So, for instance, we use
Randy, just sorry to interrupt you. From what I can just see on screen just then, what's the closest line to that pier? What does that take you to? Because you've got land poking out of that pier, if you know what I mean. So, whatever sight line you can draw, literally crossing past that is that, isn't it? Basically.
what here?
Yeah. So if you can draw a line that literally shaves the edge of the pier from your position when you took these images, whatever you end up on in a straight line, we've got to obviously account for the fact that this distance, there's a tiny amount of curvature that Google's going to introduce, but ultimately speaking, it's going to be pretty much of a muchness, I would say, if you can draw a straight line that literally shaves the edge of the pit there. Perfect. Whatever you've landed on is going to be that mountain.
Right, so there you go. So you've just that just shaves the.
Hold on, no, you've just hit land though. Before you've hit that, there's land in the foreground.
Hit, Southport.
There you go.
Yeah, 30 feet, 40 feet.
Oh, okay. Well, let's forget that then.
It won't be that. 200 feet. Straight line of sight. You've got a 1,500 feet here.
Bingo. That's what it is. What's the distance to that one?
Properties on that. 54 miles.
Can you just do the curve calcs on that one? 54 miles. See if that one's
Touch
visible.
and go whether you should actually see it.
Well, we might be able to.
1472 we refracted. Without any refraction, just straight hidden 1734. So yeah, it should be gone.
Long gone.
But how much are we seeing of it though? That's the thing. How much? In my opinion, we're seeing quite a lot of it.
More than none.
More than the tippy top, more than none, and we're looking up to it as well.
So do we need another retraction here?
We need a compass, is what we need.
But we're looking up at it. We're definitely looking up at that, right? As Ranty pointed out a couple of minutes ago, that pier's 30 foot. Halfway along, it's 15 foot. It's to look at that point on the pier, he is definitely looking up. And the line of sight to that mountain is above it. So he's looking up at something that's below his feet.
Proximity.
It's literally below his feet, round the curve of the earth. It's dropped, and he's looking up at it.
So we're talking about the line from the pier to the edge of the south pier, right? I'm sorry, from his observation point past the south pier.
What we're saying is something that's below
saying.
his feet on a sphere, he's looking up at. That's what we're saying.
No, but we just drew a line from here, where he was standing, past the south pier, right, to determine the sort of range of what he can see.
Yeah.
Yeah. Because his observation location and the south pier are very close together, if his observation location is not exact, like completely exact, that introduces a wide wide variation in the angle. If he's like 4 or 5 meters further out, he can see a lot more of the eastern mountain range.
How well pegged have you got your viewer position, Ranty?
I'd say within a couple of feet for sure.
Yeah, how'd you prove
Did
that?
you?
Pretty hard. That's pretty hard to prove.
How'd you prove that?
Well, it's at the video.
Just give me a couple.
Yeah, I might have it on the beginning of the video. Let's see what I do at the start of the video. Normally I pan around. I don't know.
Well, how did you get down to the? Where was your entry point to the beach?
It was here.
No, sorry, I meant on Google Maps.
What? My entry point on Google Maps. What do you mean?
How did you get to the beach from Google
how
Maps?
far out,
Which way did you
how
get
far
out
out from the shoreline is the
parked up on the promenade and walked across. Hello?
You?
Yeah, I'm digesting what you're saying and looking at your images.
Yeah, so we have the big one, and then we have the pier. Obviously, that's part of the pleasure beach. Google Earth. There's the pier, and there's the pleasure beach. That location.
But just imagine your location is like 5 meters to the left of where you are. That makes that line that you've drawn from that point, the error at the other end of that line is huge.
Correct.
What do you mean the error at the other side?
If you're 20 feet further left in this picture,
right? So if I'm left now, right? So and then we
extend that line, touching the pier, and you'll see at the other end of it, it's it could be a couple of miles different.
What, to here, you mean? So if I put it to there, 58 miles, go back in and we look at that one. Properties. Sure. Say I was there then. Let's do that, shall we? Just for argument's sake. Still takes us to these mountains.
But it brings into play some of the other mountains that I picked out.
I'm willing to go with this, Runty. So the next mountain along is further away, and just by looking at it on Google, looks higher. So can you just do the curve calcs again for the next mountain to the right? Because
okay, so we've got the highest mountain visible, which is this one, isn't it? The one that grazes the pier, I would say. That looks to me like the highest one. The rest look slightly lower. Would you agree with that?
So we've now forced the angle for that first mountain to be the second one along that you've just drawn a line to. So if we go with the second one,
if I just put a line in across here then and find out which is the highest mountain, line in from there across to there, and then we do the elevation profile. The highest point is right in the middle there.
Okay, well, let's do the curve calcs for that. Let's get the distance.
2,300 feet.
But how far? Because obviously it's further away.
Yeah, it's further away. Yeah, so your aspect ratio is going to change. Let's do the curvature calc on this from there.
Gotta be honest.
3 miles.
Hey, Peanuts, can you hear us?
Hey.
Good to have you.
Hey, what's going on?
63.3. So let's do 63.3. 2,000 feet hidden, 2,400 feet without refraction. Drop 2,600.
I've forgotten the height. I've forgotten the height now. What was the height?
Yeah, I've forgotten to actually. messed up. 2,200, I think it was.
So 200 feet gone. Again, definitely
Easily.
looking down at this. Yeah, so again, we're looking up at this mountain, despite the fact that it's below your feet, if it's around a curve.
Yeah, there's absolutely no way you should see any of this.
Hey Nathan.
Hey, Peanuts.
Hey, can you just explain kind of what he is disputing? Because I'm still confused.
Hang on a minute. This is arguably obfuscation, and it's derailing the point. Perhaps the way to deal with this will be to rewatch the rerun. We're at the point where now we've literally got to concede something.
Well, these wind turbines, you see these wind turbines over here? They're like 300 and odd foot tall, right? And the mountains appear higher than these.
I
There
think
is
to
a
solve
slight
it, you just
more-
got to take a compass next time.
Well, we've
No.
just done it. We've just changed it to a different mountain. And, you know, if you're saying that the first mountain is actually the second mountain, we've just done the maths for that. Both have gone. They're both below your feet.
So your
It's
get
like,
out is that we need a compass, right?
Yeah, to make sure that we're seeing. If we had a
Right,
compass, we could actually draw a
I'm calling-
line from the
I'm
observation
calling
point,
bullshit on that. We don't
Okay,
need
so
you know,
So the
100
fact that you
miles,
can
and then
see
get
the
the
very
Hold on,
glaciers
let him get his
profile
objection
here.
in. Hold on, don't jump all over him. If his objection is we don't know which mountain, let's hear it.
That is the objection.
No. Your objection is that we can't validly invalidate your claim that all this was wrong because we don't have a compass. That's the claim.
Oh, no,
That's
I'm happy to leave it up in the air.
Well, it's not up in the
and
air.
I can
We've
go
just,
away, yeah.
well, I mean, this is not in any way up in the air. So you said if he was 20 feet closer to the shore or closer to the land as opposed to the sea, it would change the mountain. So he's then changed the line, made the first mountain the second mountain, done the curve maths, and it's gone. So where do you want to go
Yeah,
from
but
here?
I
Do you
don't
want to
know
put him?
which-
Do you want to put him on?
those
Do you want to put him
mountains
on the
looking at
actual
way
brick?
back.
Do you want to put him on the road? What do you want to do next? Because we've just done what you've asked and moved him. You know, he's
Yeah,
saying
but
he
I
knows
haven't
where he
looked-
is.
I
You're
haven't
saying he
looked
could be
for
closer.
mountains
We've
east
moved
of
him.
where I had looked. 'Cause I was
But we've
looking
just done it
through
for you.
through the wind farms.
But these aren't through the wind farms. They're left of the wind farms, and
That's the
we've
point. I haven't looked east of
Yes.
the wind farms.
just shown you.
the
Literally,
there's
just
the wind
shown you.
farms here, start here,
Yeah.
and there's the pier. So we have a big gap there between the wind farms and the pier, and you can triangulate the positions. If you look at the start of the video, you can now see exactly where the pier is, where everything is, and it's exactly where I've told you I was here. And we have to be looking at these mountains because they have to
No, we don't.
bypass these wind farms here. So we have this area
and again,
of land
if
here.
you haven't got
that
your
we have to
position
look through.
absolutely correct, that changes
Huh?
things.
Okay, well, we
further
can
into the
limit it
line.
one step further. So, I mean, I can see from his picture that he's nowhere near, you know, just entering the beach. He's long on the beach. But if you do the line again,
Yeah.
Ranty, and just move yourself so that you're, you know, a few feet onto the beach rather than clearly way out into the beach and see where that
Okay.
takes us, see which mountain that lands on.
Okay, let's put myself further out and put myself here.
No, other way. Towards,
Oh.
so you're closer to the buildings rather than to the sea.
Crikey. Right, okay. I'll tell you what, let's put myself there, shall I? Shall I put myself right? So I've just literally stepped onto the beach.
Yes,
Right.
because now that limits it. It's going to be one of these three. The first one,
so I
which is
have
where
to-
you
I
say
still
you
have
are.
to
The
be
second one
beach.
where we move you a bit closer to the buildings or land, whatever you want to look at it. And now this one is, you know, like you've just come onto the beach, which you clearly haven't. This is last ditch
No.
effort to try and force this mountain to conform with any sort of sphericity.
Okay, so now I've put myself around about 20 feet, 30 feet or so on the beach.
Which is definitely wrong.
It is definitely. In fact, let me measure that actually. So yeah, a third of a mile. Sorry, 0.03 of a mile. Sorry. So now I'm looking up here on this line of sight, just bypassed here. I've got a very, very small window now to look through. Got one mountain range, which is, this would be the first one. It keeps messaging. And then these other ones would have to be in the view too, because we've only got this part here.
Well, let's let Ruhif pick your poison. Which one do you want us to do the measurements on?
No, I would grant that most of those mountains, whatever that range is called, should not be seen.
Excellent. So that's a full concession. None of this stuff should be seen on the sphere Earth, and we're looking up at it.
No, that's not what I said. Who's got echo?
Okay, well, let's do the first one. Let's just see whether or not we can see this on a sphere Earth.
The Cerny brain one,
The
which
one in
I
the
thought we
near
could see very
foreground,
good,
closest
and that
to
is
us.
to the left of the wind farm.
So this one mountain here. So you're saying that this is just one mountain that we're seeing. We're not seeing 2 or 3.
My Google Earth is not showing me elevation right now, so I can't actually search to the east of what I've already done.
Put a tick in your terrain box and it'll show your elevation.
So
where do you do that?
hello? You
Just
still
one
there?
sec. Just let Anthony explain something to Ruhif.
Yeah, sure.
If your elevation's showing a 0 on Google Earth, it's because your terrain is not got a tick in it.
Very good.
So put,
There you go. That helps.
Can you just... Oh, it's okay. So it's on mute now. You carry on.
All right. I'll mute while I have a look.
There's no rush. I'd rather there be dead air and you get a good chance to look at it, so...
Can you stop presenting me for a second, Nate? Just need to go to the bathroom.
so while he's gone to the bathroom, he should have turned himself on mute, but otherwise we're going to get a scene out of Lethal Weapon where Leslie Nielsen goes to the bathroom.
I think I'll pop them all on mute rather than listening to Ranty's bathroom exploits. You can't hear Skype at the moment, audience. While this is going on, I'd just like to point out that Ruhif is dressed as He-Man. Aware of that.
It's not He-Man, is it? Oh yeah, it is He-Man.
It was He-Man. He-Man was one of my favourites when I was a kid. By the powers of Grayskull.
I have the power.
I was watching like a rare toy show on YouTube the other day, and they had He-Man and Battle Cat action pack or something like that, and it was worth about 20 grand. And I was like, I had one of them. I remember ripping the box to shreds and getting that out and playing with it, and then eating half of his armour, as kids do.
Gutted. Only you had it now, eh? In its box.
Nah, I really enjoyed playing with that. I remember looking at it thinking, 20 grand, yeah, but I'd erase all of those childhood fun memories with that fun toy.
So what are we waiting for? Why has it come to a stop?
Because Ruth's just having a look at the elevations of various different mountains, and I'd rather give him the time to do so. It's not like we're in any hurry. We've only been going about...
well, in that case,
40
while
minutes.
he's having a quick look, I'll get a shout into somebody that I need to give a mention
Sorry.
to.
I'm in a hurry to go to bed, if that helps.
Yeah, so I know you're beavering away, mate. I just don't want to put any pressure on you, so we're just talking amongst ourselves. Just shout up when you're ready.
All right. I'd actually rather... is Ranty able to put the video on Dropbox somewhere?
I can perhaps upload it to my Google Drive if you like, and I'll leave a link in the description.
That'd be much better.
After this is finished, yeah.
You want me to put the link in the description, Ranty?
Yeah, hang on. Let me upload it to my Google Drive, and then I'll send you the link, and you can put it onto the video if you want.
Cool. So I may be on a wild goose chase. I need to see the video to figure that out.
Sure.
It may also be that the Earth's flat and you just got a misconception.
Maybe. Actually, did you watch that video that I sent earlier today, Anthony?
No, I've been busy all morning. What was the video about?
There are actually two. One of them was a video by Individual Perspective, which he put out yesterday, I think. And the other one was about Polaris, which was, you know, if I couldn't make it tonight, was going to make my point for me.
Yeah, no, I've not seen either. I did say that I wasn't going to watch the Polaris one because I wanted you to explain the trig. I wanted to go through the trig with you. Are we still good to do that?
Yeah, it's 1 o'clock now. How about we do? I'll play this other video for about 20 seconds. 1 second. Oops. There we go. Share. Hold on. All right, so that one there. Will do. Ready, Nathan, to share?
It's up, yep. Everyone can see it.
All right, so this is
I
the
just need to
guy.
share with Skype. Just give me 2 seconds. Sorry.
Individual Perspective. Put it up a couple of days ago.
I did see this one.
Say again?
I did see this one because it was only short. I saw the first 4 or 5 minutes of it.
Yeah, just watch the next 20 seconds. That part.
Looking at a load of turbines, right?
Yeah, but some of them appear to be underwater.
Appear to be underwater.
Yeah. So if I go back,
Can you? Well, I'm watching it on the delay, so I'm not sure specifically which you're referring to. If you could pause it on a bit that's underwater, and then maybe you can't see through water, right?
There we go. Whoops.
There's one in the background that's about 3 times the size of the ones in the foreground. That's the one he's referring to, I think. Am I right?
Oops, hang on. Again?
You have to give me a sec because I'm watching it on the delay. So,
Oh, sure. All right.
is it 8:25? Is that where you've stopped it?
That's where I've stopped it. Yeah. I could probably go.
Hang on. What is it I'm looking at? Talk me through what I'm looking at.
This guy is from Formby Point, and he's looking southwest or so. And he's saying that you can see Anglesey, which I don't think you can. But he's sort of missed the fact. Like see where I've got the video pause there now. So those two, are pretty much underwater, right?
The ones that the ones in the background that are bigger than the ones in the foreground. Those ones, yeah.
I don't know if they're bigger, but yeah.
Yeah, they're definitely bigger. I can see just by looking at it.
I'd agree.
If you look at the size of the blades of the ones that are really low down on the horizon to the size of the blades of the ones that are higher up, they're all the same size. It hasn't diminished in size. So it's a perspective problem you've got here.
I'd say they're bigger, significantly bigger, not the same size.
Well, okay, they're bigger, but they should be smaller, shouldn't they? They should be really tiny.
But why does it matter? Like the blade is clearly underwater.
Well, it's behind.
No, it isn't clearly underwater. Because if it was clearly underwater, the land behind it would also be behind the curve of the Earth, right?
Well, it depends how high it is.
Not really.
But this is at water level, right?
Well, no, I see his point. I think what the point Anthony's making is these wind farms aren't very... the distance between the front one and the back one isn't going to be as significant as the drop that's going to continue beyond there because it's an exponential curve. So presumably, if that's how much it's dropping based on those wind farms, that land definitely ain't going to be there, right? Because the curve's so severe by the time it gets there.
And can I just point out that...
You're making my point for me with the wind farm.
No. So we've got more than the wind farms. We've also got land. And if you're saying that the wind farms have dropped because there's curvature, then that curvature beyond those wind farms gets worse, exponentially worse. So what the hell's the land doing in the background? It should have dropped long behind the curve if that's how much curve it's dropping by.
Oh,
that's a significant amount of curve between that front wind farm and the back wind farm, yet the land still seems to be there. Well, that curve is going to get worse beyond that wind farm, isn't it?
Yeah. How high is the land?
Well, we don't know. We need to establish these sorts of facts if we're going to
So
assert that that's curvature, don't we? I'm
gone.
not asserting it's curvature. You are. So you tell me, how high is that land?
See it in this freeze frame.
Well, you tell me. You can't just pick and choose the bits you want to prove curve with. There's land there too. There's multiple targets. So if you're going to say that that's a curve, I want to know whether or not that land behind it suggests that the curve has continued and loomed up that stuff that's further away quite a considerable amount, you know? Let's see what kind of effects we've got in refraction and get those tied down. Because if we're going to have a curve that's so big that it brings half a, 250, 300 foot fan down to sea level, then I would expect the land behind it to be long gone.
Well, no, we're talking about some of the same mountains that we've just been looking at. So this Carned Dafid is 3,425 feet. And we're actually closer to it than we were at Blackpool. So it's obviously going to be seen.
This needs a lot more explaining. I think this is a red herring. You've gone away from your original video to us about the mountains that were crossing the end of that pier.
That's a good point.
Yeah, I would love to see your raw video for that.
Ruhif, can I ask you a couple of questions?
The show will either be in the link. If you don't get it from us because you nip off to bed, Ruhif, just check the link. Just check the info box after the video.
Hopefully go to bed in, I don't know, 20 minutes or so. What was Randy going to say? Oh, no, sorry, Anthony. What were you going to say?
Are you familiar with refraction soundly?
Sorry, refraction.
Are you familiar with refraction soundly?
The video? No.
The content creator known as Soundly. We call him Refraction Soundly.
I know. Oh, right. Yeah, I know him, but I don't really know his stuff.
Okay, he did an experiment called the Little Tensas Bayou. And what he did was over an 8-mile distance, he found a bridge that had a lot of stanchions that held the elevated roadway above the water. And he hanged well, I don't know if they were LED lights, but he hanged lamps off the stanchions at roughly a mile interval. And he showed that over an 8-mile lamp, so we had 8 lamps over about 8 miles. Weren't quite a mile, but it was as close as damn it for the sake of this demonstration. But what he showed was over the distance, you could put a straight line through it and you could see that they all danced up and down. However, when he got
you showed me that video the other day.
Say again?
You did show me that. You showed me that video a couple of days ago.
Yeah, but what he also showed was when he came to what he called was the results. He showed that the first 2 lights started to curve away and the third light was missing completely. And then everything thereafter seemed to be missing as well. And he claimed that was the curvature of the Earth, but didn't consider that the curvature of the Earth that wasn't present on the side profile that he did a time lapse of was important enough to mention. So my query for that one was, well, the lights appeared to be straight when you were looking side on, but when you were looking down the length of them, it appeared to drop off the way he showed it in the results. Now, it appears to be the same thing here. It looks like the stuff appears to be dropping in the foreground, but clearly the land in the background is a bit of an issue because he identifies Puffin Island, which is 40 miles away, and it's in the picture. Puffin Island isn't tall enough to be seen if we live on a ball.
Oh, sorry. Yeah, he misidentifies a lot of stuff in this video.
How do you know?
Because the sunset at the start. If you share my screen.
By the Puffin Island.
But you've accused
he's misidentified almost everything
stuff at the beginning of this stream, and then we've gone off that subject. So you've accused Ranty of misidentifying some of the land. We've just literally let you have your own way, draw your lines however you've liked, and in every instance he's gone, no, my assertion stands, all this stuff's gone behind the curve of the Earth. But now we're on to this, and you're saying, well, this other guy who's not here right now, he's misidentified some of the land.
Yeah, my claim is that individual perspective misidentified almost everything in the video.
Well, let's go with the Puffin Island example. Let's go with the Puffin Island because further in this video that you're showing now, Puffin Island sits in amongst all these turbines. So can you show us the part where he identifies Puffin Island and then show that it's not right?
Oh, I don't know if Puffin Island's not right, but you definitely can't see Anglesey.
Hold on. So
basically, he's from Can you?
Puffin
Am I
Island
still being presented or no?
I don't mind what we pick as a landmark, as long as we know it is what it is, sort of thing. So is
Puffin
Puffin Island there or
Puffin
not?
Island.
Right, Puffin Island is part of Anglesey. So if he's got Anglesey wrong, then he must have Puffin Island wrong. And Puffin Island stands by itself.
So what could we be looking at?
Let's. If you think he's got it wrong, let's see what you think he's got right. Let's challenge that, because the elevation of Puffin Island is very little.
Well, Mark's been trying to say something for a couple of. Can we all just, because Mark's quite quiet? Go ahead, Mark.
Hello, yes. Can you hear me?
Yes.
Yep.
Yeah, Puffin Island was on that just a couple of minutes back in the video. You can't misidentify Puffin Island. It can be nothing else but that.
Let's have a look.
You're still presenting, Ruhif, if you can just scroll back the video that's up on screen at the moment.
Oh, to the video. Sorry, I was going Google Earth. All right.
Yeah, if you can scroll back a couple of minutes. We've got plenty of time. I don't mind just letting it play.
I don't. It's 10 past 1.
Sorry, but if you don't mind, just so we get Puffin Island pegged, because then once you're gone, we can do the curve calcs on it.
All right. My internet's not exactly the greatest at the moment. Yeah, let's just start at the start. Oh, hang on. Great Norm.
That's a lovely picture.
It's very clear, and that's very good for spotting those underwater turbines at the back there.
Yeah, well, my point to that is that the size of the blade on that one right on the horizon has not diminished compared to the ones that are closer to you. It's not.
Sorry?
Perspective hasn't happened there. It hasn't gone into a vanishing point. Those blades are too big.
Like, how many pixels is that versus, whoops?
These are
clearly smaller.
Sorry?
Okay.
Is that Puffin Island? Is that what we're looking at now? Anglesey.
He says that's Anglesey, but the video started. Let me share a different. How do I? Am I now sharing Google Earth now?
It's a forest, you go.
No, no.
Hang on.
Sharing the Hangout page at the moment. You're on the Hangout tab.
Google Earth. There we go. All right. So he starts the video. Oh, that's what's happened. I've moved the power stations. That's not going to be a great point. From here, he's looking through the power stations. I've asked the guy when he actually did the video, so I can figure out what day it was and where the sun should be. But basically, he starts with the video pointing at the sun, and the sun is through the wind farm, and then pans left like that and goes, that's Anglesey. I think that's unlikely. I mean, it's theoretically possible he can start here and then still pan left and see it. But I don't think you can see Anglesey because it's not high enough. It should be around the curve.
Okay, so can we just establish whether he gets Puffin Island right?
We could.
Sorry, can you just mute Mark?
Are we going to argue over 20 minutes or not? Hang on.
The only reason why I'm asking for Puffin Island is it sits at a very low elevation. So if he's got that right and that elevation from that distance, that's going to be a bit of a problem with regards to the claim of the curvature on the turbines, but also in regards to this claim of Puffin Island being not visible, because it's clearly visible.
Well, let's see. All right.
I'll just say
still plenty of turbines to the right.
Sorry, say that again.
Cool. This is his second observation point, though. I don't know whether he does it in the first bit or the second bit.
No, he have Puffin Island.
In the first minute or two?
Yeah, it was orange in the background.
Okay,
I'm pretty
start
sure
back again and let it run. There we go. Leave for 2 minutes.
There you go. It's where that Great Orme. He puts the letter over it saying Puffin Island. I'm sure he does.
Someone's got an echo, and it's very hard to hear Anthony.
It might be me.
It's Mark.
No, you're echoing as well.
It's Mark.
No,
unless you want to talk. I'm sure Mark wants to say something. That's probably why he's come off mute. Go ahead, Mark.
Sorry, what? Right, here we go. It's coming up now. There it is. That's Puffin Island there.
Oh, hang on. Go back.
Stop that. That's Puffin Island.
No, when you go on the beach.
The elevation of land behind it on Anglesey is quite low. So let's get a height of Puffin Island.
Puffin Island's tiny.
Correct. And flat.
Yeah. How was that Puffin Island then?
Because it's not a ball.
No, I mean just in terms of width.
That's right for Puffin Island.
300 meters wide.
We're not going to convince you. If you're saying that's not Puffin Island, we need to forget this video.
No. We need to disprove that it's not, because if we can prove that it's not, then this guy's video is wrong. But if we can prove that it is, there's some explaining to be done here.
But go back to the Google Earth terrain image.
How about we do this? Puffin Island is what, 100 feet high or something?
Yeah.
140 something feet high. You've got what's this place here? Great Orme. You've got Great Orme to the left of it, which is 679 feet, and it's very, very close to the left. So you shouldn't have to pan very much to get a very high elevation between Puffin Island and Great Orme. So am I sharing Google Earth now?
Not yet.
Hang on. What, am I presenting or am I just sharing something else?
You're showing
click on
this
your
video at the moment.
map.
In Chrome?
Just on, I think it's your screen that's up, isn't it? Click on that. No, sorry. It's not that one. You had it. Okay, well...
hang on. What am I sharing? 1 sec.
So yeah, what you were just looking at, you were sharing.
I'll share Google Earth again. All right, so he's looking at Puffin. Says he's looking at Puffin Island.
Yeah.
Yeah.
But a very small pan to the left will get you Great Orme at a much higher elevation. And closer, so it should be huge, right?
Okay, go back to your picture of Puffin Island, and there is a bit of land that you can see to the right of it on the horizon.
Sorry, yeah, Google Earth or in the video?
In the video, it would be. His point is that Ruhif's point is that if it is Puffin Island, to the immediate left of it should be something that is not only considerably higher but considerably closer. So therefore, from our point of view, in that video, it should be enormous by comparison to Puffin Island.
Yes.
Play the video. Let's see.
Oh, hang on 1 sec. Back here.
You can actually see a bit of land.
There you go. So he says that's Puffin Island, but very, very close to it should be a much higher.
That's Great Orme there, isn't it?
Yeah, that's probably Great Orme, I'd say.
Okay, so what's the bit of land?
Or maybe not, actually.
Hang on, I don't see what the problem is. That's consistent.
Yeah, that seems pretty consistent with exactly what I was expecting to see.
I disagree completely. That's a huge pan to the left to get to Great Orme.
No, it isn't.
Huge pan. He
What are you
zoomed right
talking
in. He zoomed right in. You can move it a hair and it'll move that much.
It did exactly what you said you would expect it to do.
Yeah, and there's another land. There's more land here, and then you got Great Orme.
And look what that land is on Google Earth. Let's identify that more land that you're on about. I can tell you what that land is.
Well, we can only do that in reference to Puffin Island, which I don't think is correctly identified.
Then you're a denier.
Again, a problem could be solved with a compass.
No.
Wow.
A problem can be solved by looking at the evidence and deducing from the evidence what you're looking at. If you don't think that's consistent with what that guy claims, you're a moron. No offense.
No need.
I missed the first bit of that.
No, seriously. You're a denier, and if you're going to rely on a compass because that's your get out, again, that's nonsense. So
it would make it a huge amount easier to identify things, right?
No. Opening your eyes and could you not do orienteering when you were a kid?
I did, and we used a compass.
Right, but you also read maps. Are you able to read maps?
Yes.
So why do you not consider that to be Great Orme? It did exactly what you asked it to do at the right place. The land in the middle is the land between Puffin Island and Great Orme. Can you not see that?
We're disagreeing on how much panning is involved.
Right, but this is real world evidence against your perception of map reading.
It can only be what's there. I mean, there's no other options. What else can it be? He's got something that he's claiming is this Penguin Island or whatever it's called, and then immediately to the left of it, you're saying it's a huge pan, but it's not. He's zoomed right in.
Yeah, and we learned from the Isle of Man observations that it takes quite a lot of movement, and then you think you're going a big distance, but actually you're going like half a degree. So, perhaps the issue here is that you're not scaling correctly in your mind.
Well, that's what I said. We disagree on how much panning is involved.
I'm going to make an assertion.
One of us isn't.
Ruhif, I'm going to make an assertion, right, and then we're going to move on because I want you to deal with your trig point. He's got Puffin Island correct. He's got Great Orme correct. You've got your perception wrong. However, Puffin Island should be totally behind the curve of the Earth at 40 miles, and it's 100 and odd feet. Call it 250.
I think I agree.
Right. So what I want you to do is go away, find out what you think Puffin Island is if it's not Puffin Island based on the evidence, and then come back tomorrow or the day after and tell us where it was that we went wrong, and tell us what that land actually is. And then tell us whether it's behind the curve of the Earth or not, and does it match what we see?
Yep, I'll do that. I would like a response from the guy to tell me what day he actually shot the footage.
What's the sun got
that'll
to do
give
with
a good starting point. So again?
What has the sun got to do with it?
It gives you a good starting point.
No, because we don't consider date and time to be reliable. Dateandtime.com.
Yeah, but it'll still match observations, right? If it tells you that the sun sets at 240 degrees.
No, at all. I've tested it.
Antonio did a really good experiment showing the claims on Sun and Moon. Was it not Sun and Moon? Dateandtime.com. He was doing an experiment with regards to where the sun was meant to rise and set, or on the equinox. I can't remember exactly, and he showed that it was wildly wrong. Correct me if I'm wrong there, Nathan.
When you say wildly wrong, how much do you think it'd be wrong by?
Nathan, can you remember what the point was with Antonio's sun observation?
It didn't match, so it'd say it would come up at a certain time, and it wouldn't.
Oh no, the direction.
Same direction.
When you say wildly inaccurate.
Oh, it's just not accurate.
Yeah, but by 1 degree.
Well, sometimes it was off by a whole hour. Sometimes it was literally out by an entire hour.
I'm gonna say it makes no difference whatsoever with regards to the sun.
Time and date would be out by an hour. It would say it would rise or be at solar noon or set at a particular time, and it would be out by an hour. It happened a couple of times.
All right.
I mean, don't get me wrong. We did literally. It was 48 hours solid of testing.
I'm gonna conclude by saying that it's irrelevant, the sun point. So you can dwell on it if you wish. I don't care what figures you come back with. All I want to know is that Puffin Island according to your perception or not? And if it is, I want you to explain why it's not hidden.
It's hidden.
It's 40
it should
miles.
not be seen.
It should be well behind the curve of the Earth.
Agree. Who's echoing?
Mark.
Right.
I've turned him right up. It's my fault because he's so quiet. I've turned him right up, which is causing a bit of echo. But did you want to say something, Mark?
Yeah, I agree. Puffin Island should not be seen.
So I think you're heading for a fall there, you know.
Well, we'll see.
I agree.
We'll see.
Now, let's go for your third point if we're ready to move on. I don't know if Matt wants to speak, and if he does, say so now. Otherwise, let's go on to the trig.
Yeah.
Matt?
So hang on. Are you going to critique it, or am I going to do the whole thing again?
No, I want to know, does Matt want to speak at this moment? Because if he doesn't, let's do the trig.
Okay.
No, I'm fine. I'm fine. Carry on. I'll just mute myself.
Thank you.
Okay, great. So the trig from yesterday, I missed the trig from yesterday, but you said you made a claim yesterday that I'm not 100% sure. You'll have to correct me on where I go wrong, but it looked like you were saying that if the Earth was flat, then the trig would prove that the stars were close. Is that what you said?
Not quite. Not quite. If you assume a flat Earth and you try to triangulate the height of Polaris, you will get a number. If you then try and use that number from other places on the flat Earth, it won't work. So that video that I sent you this morning, my time, it gave you sort of 4 or 5 different observations to say, like at this latitude, Polaris will be at this elevation. So at 87 degrees latitude, it'll be at 87 degrees elevation. At 45 degrees latitude, it'll be 45 elevation. And if you know the distances between the North Pole and all these viewing locations, the trigonometry would place Polaris at different heights.
That's it. The trigonometry is on paper. If you were underwater looking upwards at a star above you, and then you moved to one side and take another measurement and then another measurement, it would change because of the refraction of the light coming through the water. And
are you saying that refraction is quite a powerful phenomenon?
Well, we've got atmosphere above us, haven't we? And
yeah, but it's looking horizontally through the atmosphere, not at high elevations, right?
If you try and catch a fish with a spear in the water, you've got to imagine the fish to be somewhere else than it actually is for you to.
Yeah, and what's the refractive index of water compared to the air?
I'm just saying that for argument's sake, that the atmosphere.
I'm just saying you shouldn't be the one to overemphasize the effects of refraction. That's what I'm trying to say.
Well, no, I don't buy your argument about the Polaris, because we've got, I don't know how many miles of atmosphere we've got above us. But you can't just say on a flat Earth, because it appears in different positions, you can't ignore the fact that light is coming through quite a few miles of atmosphere.
I'll restate what I just said. Be careful overstating the effects of refraction.
There's a pause. Who's waiting for who here?
Oh, I thought you were keep going.
Well, I'm just wondering what trig we can do, because I'm not quite sure on the point now, because I thought the point was to do with the stars. So the point's not there, so I'm not sure how we can test the trig without going to an absolute load of different variables on different latitudes, and that's not going to be good viewing. So perhaps I don't think we can do a trigonometry test at the moment, because it involves a lot of trig, and I don't think that's going to be fun to watch. At least we've got the Puffin argument, the Puffin Island argument, and you agree it should be behind the curve of the Earth.
We can do a simple trig, right? We'll do like two triangles, right? So if you're on a flat Earth, Polaris, and you're at the North Pole, Polaris is directly above you, or 89.5 or something degrees, but it's effectively above you.
So the claim goes.
Yeah, I mean you can.
You like that?
Where you're like at 50, you're at 54 or something degrees north now. I mean, you can go and check Polaris tonight, and then all your flat Earth friends around the world can check Polaris. Sorry, all your northern hemisphere friends can check Polaris and check that it equals their latitude.
There it is, because the light is coming through quite a few miles of atmosphere.
I missed the first half of that.
You don't have any proof for that. You don't even have a proof that the atmosphere ends at some point. Buoyancy.
I would say that I do.
Would
I mean,
prove the
it
contrary.
depends on the ISS. We can triangulate the ISS as well. And if you want to say that
we're all
structure,
hijacking Ruhif's point. Look,
on paper,
Ruhif's got a point, and I want him to make it. We're all hijacking him. So he's on his own. There's 4 flat earthers, 5 flat earthers, and he's making a point about Polaris, and he's being pulled from here pillar to post. So can we just stay on track? He's got his basic assumption, and I mentioned it yesterday, and so has Mark or someone else, is that we assume that we're directly below the North Star at the North Pole.
Yeah, that's a pretty safe assumption. I mean, if everyone's observations around the world are consistent, then yeah, it's a pretty safe assumption. Anyway, so we'll go with that assumption. So if you're at the North Pole, Polaris is directly above or near enough to be directly above. If you are at 45 degrees north, you are approximately 5,000 kilometers, 5,000 Ks from the North Pole, I think. Yep. So pretty simple trig there without even having to do the numbers. That puts Polaris as 5,000 kilometers above the North Pole. Do you agree that's the trig?
What?
Sorry,
say again.
Why?
Yes, on paper.
All you really have is a relational angle.
It's at a 45 degree angle, so the opposite and adjacent sides, like tan 45 is 1, right? So the opposite and adjacents are equal.
Yeah.
But how would that prove any literal distance? It's just how much the angle of the heavenly body in relation to the observer changes over a distance on the Earth. That's really all you can get out of that.
And you can see where those observations intersect.
Yeah, but the only thing you really got is how much the angle difference is of that heavenly body in accordance to the observer as you move over the Earth. That's the only real information you're getting out of that. You don't actually know the literal distance to that star that's over there.
Yes, you do with trigonometry.
No, you don't. No, not at all.
How? If you're at the North Pole,
the only thing you got is how much the angle difference is. That is the only thing you get out of it. How much distance in kilometers, or however you're going to measure that, on the Earth does the angle difference of that heavenly body shift? That is all you can get out of it.
No, you're at the North Pole. You look straight up so that you know that Polaris is on that vertical line. If you then travel 5,000 kilometers south, anywhere on the Earth, Polaris will be at 45 degrees, which tells you how high it is.
No, it tells you how much angle difference that land distance makes.
Can I just ask a question? You just said then if you go to if you go all the way down to the equator, or how did you word that?
Yes.
Just say that again.
Oh, I said if you went to 45 degrees south, 5,000 Ks. I mean, you can play with the distances if you don't trust the Google Earth distances.
Sure,
that's fine.
So your words were, if you go down to 45 degrees from anywhere on the Earth, Polaris would sit on the horizon. Yes?
No. 45 degrees. The angle of elevation is equal to the latitude. So if you go 45 degrees north, which is, where are we? Hang on. 45. I don't know, Spain somewhere, France, wherever. Yeah, wherever. If you go somewhere on the 45th latitude, Polaris will be at 45 degrees elevation.
Okay, so if you go down to the equator, Polaris will sit on the horizon.
Yep.
Correct?
Yes.
At that point,
correct.
At that point, does that tell you that we live on a ball?
It tells you that we do not live on a flat plane.
Why?
You can construct a ball. Well, like I said, if you're at the North Pole, Polaris is above you. If you're at 45 degrees and the elevation of Polaris is 45 degrees, you've traveled 5,000 Ks from the North Pole down to the 45th degree of latitude. So we know that Polaris is 5,000 Ks high.
No, you don't. You don't know any literal distance. You just know the angle.
Like high school?
Correct.
All you got is angles.
Well,
it's the only thing you really know. You know the angles of the heavenly bodies. This is very easily measurable. How much distance causes how much of the angle to shift and in what direction and all that. But you don't know any literal distance, and you don't know any literal size of those objects.
Can you mute whoever's echoing? I can't hear Arwen.
You should make your point.
Whoever
again,
doesn't
Arwen.
have headphones need to mute.
Gonna make your point again, Arwen.
Okay. My point is all you know of the heavenly bodies, all of them, is what angle they are on the edge of your vision, basically. They're there, you can see them, and you can see how that angle in relation to the observer changes as you move over the Earth. So you know how much distance moving over the Earth will change the angle of that heavenly body in accordance to the observer. But you don't know any literal distance, and you don't know any size, so you can't accurately triangulate it.
I agree.
You don't have that information, and you're probably never going to get that information.
Hey, True Seeker.
And hey, if you're going to move upwards in the heavens, basically moving up in a balloon or whatever, during a starry sky, yeah, you could then try to approach such a star or get a clearer view, but they'll just disappear from sight.
Alan, if you wanted
There's
to know
no
the
proof
height
that
of
there are actually physical objects out there at all. It's just light.
Go ahead, Mark.
If you wanted to know the height of a church steeple, you walk to a point where your vision is at 45 degrees to it, you know the height of the steeple.
Yeah, but there's a big difference. You can approach that church.
No. You know how far across the ground it is to the steeple.
Touch it.
Yeah, that's right. That's what I'm saying. Tan 45. If I'm 100 meters away from the steeple and it's 45 degrees to look up to the top of it, then I know the height of it. That's your argument, isn't it?
Yeah. Yes.
Alan, how do you?
But you can prove that's a physical object.
Hang on. We're missing the trigger.
We had this argument.
It would be a physical object, wouldn't it?
I don't care if it's a physical object.
Church will definitely be a physical object. It was built
above the North Pole.
Hang on. Wait. We're getting the trig bit wrong here, because if you go down to 45 degrees to do the trig to ascertain the distance, right? If you do that on a flat plane, you get a distance that's flat. But if you do that on a curved ball, by the time you get down to the 45th degree, that opens the angle up significantly so that the star becomes a lot further away. Agreed?
Yes.
Right. So if you do the trig on a flat plane, the stars appear to be the way they appear in real world, which is pretty close.
No, we've only done half the trig. The first part was to establish the height of Polaris.
How did we establish the height of Polaris?
Well, if you're at the North Pole and you look directly up, Polaris will be there. At that point, you don't know how far away it is. But if you go 5,000 k's south, Polaris will then be at a 45-degree angle. If you're on a flat plane, that makes Polaris 5,000 k's high.
So you said this yesterday, and I said, have you got an example of it? And you were like, well, that's a safe assumption. But have you got an example of exactly that? Somebody at the North Pole with Polaris directly above their head?
I haven't looked. I mean, you guys can find as many people around the world and ask them at what elevation they see Polaris.
Right,
your starting point is always, if you're at the North Pole, and that's the start of your statement every time.
Yeah.
Right, but you're saying it's an assumption.
It's people have navigated off this fact for hundreds of years.
Okay, all right. Let's give him that Polaris is overhead at the North Pole, right? I don't think anybody knows for a fact that it is, but let's just say for the sake of the trig, it is. Let's move on from the trig, and let's move on from the North Pole point, and let's move down to your position where 45. You can do your trig from.
Yep. So now we've travelled.
Perhaps you could put.
Well, it's 5,000 k's. There again, Anthony.
Perhaps you could put your camera on and start showing us the triangle that you're about to make, so that we can do the trig on it. So let's say that you went down to 45 degrees, and then you did the trig at 45 degrees. Let's see what trig that you do.
just before you do, though, because something confuses me. So, as we're looking at things like these mountains, the further we get away, the further they drop towards the horizon.
As the Earth curves away, yeah, they need to be higher than to be seen.
Well, no, we've established that in the first demonstration where we were looking up at a mountain that should be below us. So I think that's complete nonsense, and there's nothing to back that assertion up. So that's complete horse crap. So we've already debunked that literally on this show when we looked up at a mountain that's below our feet. That's impossible. It doesn't happen. That's not how our vision works. What does definitely happen with perspective, if you go 4,000 miles away from something, it will definitely drop towards the horizon.
No, it will still be at the angle where it is.
Why?
We'll demonstrate that in a second.
No. So that's what I've just said. That's what happens. If I definitely move 4,000 miles away from something, it will drop down. That's what happens. That's perspective.
Yeah, but we can still measure the angle to it.
Well, but it's moved. It's dropped down to the horizon. Especially if it's close. If you're saying it's only 4,000 miles away.
It hasn't actually moved, right? It's still 5,000 k's up.
Right, but it's dropped towards the horizon.
Yeah, as you get away, and that's
how flat Earth would work.
Right?
That's just a different way of looking at the same thing. You can look at the exact same thing and do the same measurements and just insert the curve into the exact same maths.
All right, hang on. See that one? Does everyone see that?
Yep, you're up. You're on screen.
Cool. Now, so between the North Pole and the 45th latitude, I work it out to be about 5,000 k's.
Are we on a ball here or flat?
No, we're on flat.
Flat.
Okay.
Yep.
Confusing.
Yeah.
No, it's really? Fine. I'm good with that.
This is trigonometry, people.
Yeah. So how does it work on a ball? Show us the trig for the ball.
We'll get to that in a minute. But how high is Polaris?
Not that high.
Well, you can work it out if that's 45 degrees.
Yeah, on your paper, it's 5,000 kilometers high.
Excellent. Thank you.
Oh, sorry. I thought you were asking in real world.
No, he's asking based on the maths and the trig that he's doing on paper.
That's 5,000 k's high. Now, do you want to move to the equator or 10 degrees north?
10 degrees north, it's easier on your...
Well, yeah, maybe.
Easier to draw.
Yeah, true. 10 degrees north, so 10 degrees equals 5,000 over the distance. Sorry, 5,000 by 10. Okay, so it is from the North Pole to the 10th degree latitude, it is 28,356 kilometers.
Okay.
Okay. Is it 28,000 k's from the North Pole to the equator?
Just put your trig on. Show us what the what you've got for your thing. Just keep it there for a sec. Let me just write down what you've got. So we've got an angle of 10 degrees.
And we've established that Polaris is 5,000 k's up.
5,000 kilometers. And you should have... oh, hang on, you've got 10. So the angle, so you're changing the... Oh, right, okay, so...
Yeah, we've moved to closer to the equator.
So what's your value then that's gone? That was 5,000. What has it become?
No, it hasn't. We've kept the height of Polaris the same at 5,000. But if Polaris is 5,000 k's above the Earth, then the 10th latitude north is 28,000 k's from the North Pole.
So we've kept the height of Polaris at what did you say?
Second, Polaris at 5,000 Ks.
Bear with me. And we've dropped our angle down to 20.
Yeah, we've
10.
moved. We've moved to the 10th degree latitude.
Hang on a sec. Oh, wait. My computer's just suddenly decided to go slow. One sec. So kept that there. So we'll calculate that. So right, so 10 degrees will give us 27,000, right?
I got 28,000 something.
28,356. Yeah.
Yes.
Great. I'm on the same page with you now. I'm ready. So where are we going next?
Is it 28,000 Ks from the North Pole to the 10th degree latitude, 10th degree north latitude?
Well, my answer to that would be trying to catch a fish from the outside of the water with a spear. You're not taking into account how much atmosphere is above you.
And that's true, because if you start, I remind myself of Mick West telling us about the refraction of stars on the horizon. They change significantly.
Yeah, as they get close to the horizon, yes, they slow down.
You
notice they don't slow down just above the horizon? I'm sitting here letting you guys hang yourself with, giving refraction all this credit for bending so much light.
I knew exactly where you were going to go with this, and I'm saying to you that the refraction of the atmosphere above us is not taken into account on the recent days. And we can increase the density visually by doing it with water. So how much atmosphere is above us?
Yeah, we can't see thousands of kilometers on land. Why can we see thousands of kilometers up in the sky?
Because you've got less atmosphere to go through.
No, there should be more.
I knew already, Rufus, you probably realised, and I realised, that you had a winning point as soon as you started this, and I conceded it immediately because I knew where you were going with it too. If you do the maths the way you've done it, yeah, you've got us. I can't not concede that.
Based on the maths, correct?
But then you should be a flat earther, right?
Well, hang on. But is it based on real world, though? That's my question. In the same way that I would question the sun.
Hold on, one at a time. Don't know we'll get triggered just because he's got you.
No, hang on. I'm not. Yeah, I accept that you may have us with the maths, but it's the same thing with regards to the sun's rising and setting on the video that we were looking at, because the sun's position, what you're going to get with regard to the maths, if it don't match real world, I don't give a crap what the math says. So what my point with this is that unless the values that you're claiming here are in fact accurate, it has to match real world, and we don't have the evidence to say that it does or does not. So if we're going to rely solely on a mathematical equation, no, because I want to see the proof that it is actually correct. So yeah, you can have the math.
Yeah, that's all I wanted to say is we've moved on, because math is the illusion that keeps us in the globe model. Once we go to reality, it's clear the model falls apart. There's no 8 inches of square model.
Man, you used your compass. We can say they're intangible objects. What's the problem?
You can say they're intangible objects, but that doesn't change where they are. There is still a light there somewhere. I don't care if it's not a flaming ball of gas.
How can you tell a light isn't twice the distance away and half the size? Can you answer that?
Because we've just triangulated it. We've just triangulated where it is.
You're triangulating what you're seeing. You're not triangulating what's tangibly there in verified reality. So you're actually just looking at angles and lights, and you're not actually verifying anything.
I am exactly looking at angles and lights. Yes, that is correct.
So exactly, that light could be half the size of what you're assuming and twice the distance away.
Again, I don't care.
You're not actually identifying anything. You're just using
I don't care what size it is
tricks to make it appear as if you guys have won another point, and you actually haven't done anything. It's just smoke and mirrors to make it look as if you guys have got something right.
Wow. Again, I don't care how big it is or what it's made of or whether it is real. There is a light in the sky, and you can triangulate that point of light.
So you're assuming you know its distance. You're assuming you know the size then.
No, I've just worked it out.
It's just done it with the trig.
So what can you show me how you know it's not half the size and double the distance?
I don't care how. Verified that? I'm not measuring its apparent angular size.
You're making assumptions in your model. Okay, cool.
I don't care how big it is. I'm not measuring its angular size.
How have
I'm
you
measuring its
verified the
location.
angular size that you're measuring is the size pertaining to it?
I'm not measuring the angular size. Can I say it again? I'm not measuring the angular size. I don't pay any attention to how big it is.
Ruhif, let me get this right, because I'm with you. I think I'm with you, right? So what you're saying is that at the 45 degrees, when you measured a 45 degree, or when we were at 45 degrees, did you say that the star would appear to be 5,000 miles? Is that what you said?
5,000 Ks, yeah.
Ks. So 45 degrees, 5,000 Ks, and so on a flat plane, so basically what you're saying is the trig works against us, correct?
Yes.
I missed that. Say again.
That the trig works against us. Yes, it does.
Yes. And therefore you should not be a flat earther.
What? Because of the intangible object that we don't know what is? It is. Okay.
Again,
why don't you go there and actually prove that it is there at that distance?
Yeah, that's what I was going to ask. What is the empirical evidence that proves these angles at these distances, and how do you know that these are true? Because if this is the case, then we could also use that empirical evidence.
No, these are facts. These are facts. That's when the North Star appears at that latitude.
Yeah.
Yeah, but you only got the angle. That's all.
Hang on, I want to see
that's
what
he needs. He's got one side of the triangle because he's travelled 5,000 Ks.
And the angle.
And he's got the angle, correct. So why aren't we conceding this? Why are we doing it? Oh, shut up. You carry on quizzing him on this. You should have conceded this ages ago. And there's 2 celestial spheres.
Have you just deconverted, Nathan?
Not at all. I know there's problems. I'm trying to find answers, but I don't have the answer to what the North Star is, where the North Star is. I don't have those answers. To me, they're just intangible objects. They don't prove it's
post a video for you in the chat. 1 sec.
Same with the South Celestial point of rotation. You know, that again, you can use that all day long if you want to prove to yourself that it's a sphere. It doesn't change the land that's around me that's obviously flat.
It's the globe of the heavens. You know that's a globe.
Yeah, I can't deny that we have a celestial sphere. We do. You know, it's a fact. We do have a celestial sphere. And it maps out really nicely. And the heliocentrists have done an exceptionally good job of mapping the stars. So, you know, it does work. It is very good. I can't deny that. I'm not going to be a denier in that regard. Why would I?
But then how do you deny the shape of the Earth?
Because it is obviously flat.
Whatever we can see up in the sky has no relevance to the surface we're standing on when we can show you Puffin Island from 50 miles away.
Yeah,
well, I disagree. That's Puffin Island.
Yeah,
to be honest with you, I'm not the trig point. I'm going to think about it because it's a fair point. I understand what your point is, and I get it. I'm going to look into it and I'm going to talk about it and think about it and whatever. However, we see Puffin Island at 40 miles away, and if we live on a curve, that is not there. So unless you can prove it's not Puffin Island, that is a problem.
Gentlemen, without even YouTube that handles this from a flat Earth perspective, and it's quite good. And his explanation is the amount of refraction because of the height of the atmosphere. That's what I'm resting my answer on to the gentleman there in Australia. Is it Australia or New Zealand?
But how do you know that the atmosphere ends at a certain height?
Well,
law of buoyancy
we don't have
kind
time,
of
but
contradict that.
What are people's views on the ISS?
Spreads around.
Again?
The ISS, I'll fill that one. I have no idea what the light in the sky is.
Have you seen Red's Rhetoric film The Transit Across the Moon?
Yep.
So you saw the shape of it?
Yep, seen lots and lots of shapes of it on lots of different representations. Some amateur, some professional. I've seen lots of the ISS. Still don't know what it is.
Do you think it's a hologram or some sort of trick from NASA or something?
I don't know. What I do know from watching their footage from the inside is that there is a huge amount of fakery going on.
Well, yeah, we disagree with that obviously as well. My point anyway is that in the same way that we can triangulate a star, we can triangulate the ISS and show that it's a few hundred kilometers above the Earth. And to say
no,
that, say again, Owen?
No, you can't. You can't determine a distance of any star, or even the sun and the moon, or planets, because all you got is angles. You got the angles.
That's why I said I don't know what it is. You're assuming that it's a physical thing with men floating around inside it, correct?
Well, I don't know if that's an assumption. I have a little more trust in what I see.
No. I'll establish if it's an assumption or not. Have you been on the ISS?
No.
So you assume that it's a physical thing with men floating around inside it, correct?
Do you want to define what an assumption is?
Something that you've not verified
without evidence.
Something that you've not verified in any way, shape, or form.
I see the ISS go across my
television screen. Yes, I know. You see it internally. You see it on your television screen. What's on the outside? I don't know what it is. Now you can show me shapes flickering and various different distinctions of things that are then shown from a different perspective in very, very, very minute detail. Now, just because we can see things through a scope doesn't mean to say that someone can come up with some plasticine and modelling clay and make it look similar. But unless you're going to tell me you've been on the ISS, you have absolutely no way of verifying that it is a physical thing with men inside. None. Other than what you see on TV.
Well, I see the ISS go over, every few days, depending on...
The light. Yeah, so what?
Say again?
The light. Yeah, so what?
Yeah, it's a light, but I mean, like Red saw, he got a pretty good shape of it going across the moon. But yeah, like most of the time you just see a light, right?
It's a snowflake shape.
Sure, but just before we move on, I need you to concede this. Just because we see a light does not mean it is a physical thing with people inside it.
Oh, no, I agree. But I mean, there's plenty of evidence to say that it is.
No, so there's none. You show me it. Okay, go and get it. Show me a single piece of evidence that confirms that the ISS is a physical thing, that a light that we see is a physical thing with men inside. You show me the definitive evidence for that, please.
Oh, I said we had plenty of evidence, and part of that evidence is the fact that it has a camera on the outside, and we send rockets up there. And like, there's, you might call it circumstantial, and that's
by
fine.
That standard, if I show you a number of disaster movies that have been filmed with cameras, you're going to tell me that they're all real because they've been filmed with cameras.
No, you're just watching a TV screen, right?
Right, that's the same as the ISS, just on a TV screen. Just because it's filmed with cameras doesn't prove anything. You can trick stuff with cameras.
You see a light go over the top, right? Do you agree that you see a light go over the top?
Yeah, we've established that. We see a light, we don't know what it is. You're trying to prove that it's a physical thing with men inside, and I'd like to see some evidence
I'm not
that proves
that. Prove that it's a physical thing.
Well, it needs to be a physical thing if we're going to start measuring it as though it's a physical thing with an actual distance. If it's just a light...
Same as the star. Same as
no, I wouldn't concede that with the stars either. They're not tangible. We don't know what they are. And I would say the same for the ISS. But if you can present me some absolute cast iron proof that it's a physical thing with men inside, then we're a totally different ballgame. Then it's a physical thing with men inside, and we can measure distances to it.
But that's what I'm not trying to prove that right now. I'm just trying to prove that we can triangulate the position of that light, whatever it is.
Well, it's just a light in the sky. It's an intangible object. What's the point, It's back to you triangulating things on my projection screen for hours on end and then tell me the distances, and you say, yeah, your screen's 6 foot away. And I go, yeah, but the projector's above your head.
That's fine. I mean, you could call the ISS
that's projecting the light, the thing that's physically creating the light, if you measure stuff on my projection screen, is on a projection screen in front of you and 6 feet away from you. So you do all your measurements, you work it all out, you get the maths pegged, and then afterwards I point out that nothing on the screen is real. It's all coming from behind you, from a light-making machine called a projector.
Yeah, that's fine.
No, it's not, because if you're going to present the facts of the lights on the screen are physical things and your accurate measurements stack up to something, I'm going to say, well, they're meaningless. It's a machine behind me that's made those lights.
Prove that.
Well, you can't prove it, and neither can I, which makes it moot.
No,
they're intangible objects that you can't prove, you haven't been to, you haven't verified.
Triangulate that light, whatever it is.
Right, but it might be coming from a projector behind you, therefore pointless.
Well, you can call it pointless, that's fine.
Yep. There's no guarantee if you approach it that it's still there.
Agree?
Actually,
Do you agree that we can triangulate the position of the ISS, whatever it may be?
When you go up high enough, the stars disappear. That's why in all the footage of high up, even in the ball Earth, that famous footage, there's no stars surrounding it. Why would that be?
I have no idea, but that's not the question I was asking.
Well, that is very important because that kind of proves our point that, hey, if it is actually a physical object out there, then if you approach it or come closer towards it, then you would still be able to see it, but you don't. So how can you then prove that it is a physical object and not just an appearance, a light appearing?
Well, again,
in our view,
I'm not trying to prove that it's a physical object.
As we watch upward at night.
I'm asking whether you think we can triangulate a light in the sky, such as the ISS, regardless of what it is. Do you agree that we can know where it is?
No, absolutely not.
No, you can't. The only thing you can do is basically figure out its angle and its angular relation to the physical location on Earth. How that angle changes. That is what you can figure out.
I missed that last bit. Say again.
All you can do with all the heavenly bodies, stars, sun, even moon, planets, is figure out their angular location, their angular relation to your physical location on Earth. And if you move over the Earth at a physical measurable distance, then the angle of those heavenly bodies in relation to the observer, to you, change in a very specific amount of degrees. And that angular relation to the Earth is what you can actually measure. But that does not provide a literal distance or a size.
Yes, it does. If you have two observations from different places. Absolutely it does. If you are standing with a plate.
No, all you get is the angular relation. That is all you get.
Plate.
You can't prove that there are actually physical objects out there just by measuring it from where you're standing on the Earth.
Arwen, is your argument like a rainbow isn't seen exactly the same position as the person standing next to you?
Well, it's even with the sun in itself and the moon. You can watch the sun at a specific location during a certain time of day, and then another person in another location on the Earth would also look at the sun, and the sun would be at another angle because of the angular relation and the distance between these people on the Earth. But that, you can then draw conclusions that it must be at some kind of literal distance. You can model it out based on certain size and distance assumptions, including whether the Earth be a globe or if it will be flat. That would change the relations. But since you can't actually prove that they really are physical objects, that always remains speculation. It always remains a base assumption.
Okay. Hang on.
Right, you're presenting.
You have to actually go there and touch it,
Presenting? I'm presenting, okay.
And see that it is a physical object. Approach it. See that it grows bigger as you approach it, and then that it grows so big that it basically becomes, it fills up your entire horizon as you approach it. That would start to come closer to actually being able to prove that they're physical objects. But that's not happening. There's not even approach footage with the moon landing rocket going there. There's not even footage of approaching the moon. It's
I've got
there.
2 observers. I've got 2 observers on my flat plane. This guy sees whatever, the ISS, at that direction. So he's drawing a line straight up that way, and that goes to infinity, that line. This guy sees the ISS in this direction, and that line also goes to infinity that way. But at some point, because they're not parallel lines, those lines will intersect. Do you understand that is how we triangulate the position of something?
That's the apparent position based on the foundational model of the Earth that you're calculating with.
Oh, I'm assuming a flat plane here, right?
But you actually, it does not prove that they are literally there. Because to prove something
Again,
is literally there, you have
not trying
to go
prove
there
that they are physical
and
objects
then
or
touch the object.
anything other than
It's just an
a light.
apparent location. And you can triangulate that apparent location using this system. Yes. It doesn't prove that it's actually there. It's an apparent location.
Yeah, but it's a light, right?
It appears to us as a light, yes.
Okay, so the question was, do you agree that we can triangulate something using two observers?
No, not a light in the sky.
Oh.
Because, as I've said several times, if it's, hold on, Arwen, if it's being projected onto something, so if you're triangulating what's on my screen, and I draw a line from my position and then go to the other side of my room and then draw a line to my position and triangulate what's on my screen in front of me, and then I calculate the distances and I present you with an answer, I can then turn around afterwards and go, none of what's on the screen bears any resemblance to anything. It's coming from a projection device that's literally behind you.
Is the screen real?
The images on the screen are not real. That they're lights projected by a projector that's behind you. That's what you're measuring, the light. You're saying, I'm going to measure that dot of light on your screen, or in this instance, in the sky. Well, in my instance, a very easy analogous example, the light isn't on the screen. It's coming from a bulb behind my head.
But there is still a light on the screen, right?
Yeah, but it isn't where the light's coming from. Absolutely is not the source of the light. Has no resemblance to anything to do with where the light comes from whatsoever. It's just an apparent position of a light on a screen, and is therefore meaningless in relation to what the light actually is or where it comes from.
I don't care where it comes from. We're still triangulating that light on the screen.
Okay, but it's not coming from the screen. It's coming from behind my head. There's no light on the screen. It's just a bulb behind me.
But there is a light on the screen.
Yeah, and yet its source is behind me.
That's fine.
Yeah, for you it's fine because you don't mind triangulating apparitions of things and not caring what they are. You don't mind if it's real or not. You couldn't care less. I do. I care where things originate from and what they are, because that's quite important in reality. Yeah, you know, we're talking about reality, the nature of our existence, the nature of our world, what things actually are, and where they originate from is crucial.
Think it's all fake.
Right, I say I don't know what it is.
Yeah, and I say it doesn't matter.
Right, well I say it definitely matters if you're going to use it as proof of stuff.
No, I'm proving that we can triangulate something, that is all.
Okay. But you're triangulating an apparent phenomena.
No, okay, we've got about 10, maybe 15 minutes left. There's about 4 people on the panel, so maybe... Hold on, Arwen, hold on. If we can just start drawing some conclusions then, if you're saying you don't care about its position and it's just triangulation, I mean, yeah, okay, great, it's a fun bit of maths on a bit of paper then, unless you've got a conclusion that you're going to draw with it.
Yeah, that the whatever that light is at Polaris, the Earth is not flat. I thought that conclusion was pretty obvious.
Right.
Well, given that Puffin Island was visible at 40 miles, I fail to see how that you can conclude that when you've seen with your own two eyes that there is an island that matches Puffin Island in the right direction, and it's supposed to be behind the curve of the Earth.
Or the mountains at the beginning of this show, the mountains that aren't supposed to be there, that are well long gone behind the curve of the Earth, but we're actually looking up towards, as you would expect to do on a flat plane. They also destroy the assertion that it's a sphere. So we've got a bit of a problem there. So the question is, what do we trust? The intangible lights in the sky or the physical nature of the reality we can touch and measure?
I would trust mathematics.
Right, so you trust the trig on intangible lights on a screen from a projector that's coming from behind you, but you don't care about any of that. So it sounds like you don't care about reality. You don't care what it is. You don't care if it's real or not or where it's coming from. So long as the trig works out, maths proves it for you. Yeah. Good for you.
For the purpose of this demonstration, it doesn't matter what it is.
Right, but it's crucial.
If you're saying there's a screen 5,000 k's away, that's good for me.
Well, but we don't know that it's 5,000 k's away if we don't know what it is.
Yes, we do. It doesn't matter what it is. Why does it matter what it is?
I've said it. I'll say it again. Right. I'll say it one last time. Right. If we calculate the lights on my projection screen that I am looking at and assert that that's where something is, it isn't. The source of what it is completely in a different location. But without knowing that, you can assume that the dancing lights on my screen are a real thing that you can measure in terms of their distance. You can't. They're not real.
Is there a light on the screen?
Yeah, there's a light on the screen. But that's not the light. The light's behind me. The light's coming from a projector behind me. It's got sod all to do with what's on the screen, unfortunately. But if you don't care and you're happy to just measure what's on the screen anyway, then you'll come to a fallacious conclusion.
There's still a screen 5,000 k's away, right?
No.
Hang on.
No, the light itself is actually 2 feet above my head. Not even in front of me. It's behind me.
So you're saying there's no light on the screen?
Hey guys, could I hog the mic for 5 minutes? I've just been working on some stuff.
Yes, I'm going to go to bed, actually.
It's been Ruhif, you're a great guest. Like, one of the best.
Thank you very much. I'll try and get on again at some point.
Hey, Ruhif, before you go, make sure that you come back with either yes, it is Puffin Island, or no, it's not Puffin Island. Here's the reason why, and why you
absolutely not, because it's around the
ahead of the trig.
Say again?
When you go away, I'm hoping that you'll come back with a conclusion to if you accept the trig proves the stars that means that the Earth's not flat, then I'm hoping that the next time we see you, I'm hoping that you can tell us that that is or is not Puffin Island, and that therefore it is either behind the curve or not behind the curve, and then I look forward to your explanation for why we see it.
Yes, I can do that. For now, I guarantee you it's not Puffin Island because it is around the curve, and hopefully I can prove that. But that's for another night. I'm going to go to bed. Thank you very much, Nathan and Anthony.
It's been a real pleasure. It's been a cracking show. Thanks mostly to you. So thank you very much.
Good night, everyone.
Good night.
Do I get a thumbs up for the shirt?
Good man.
All right. Catch you later. Good night.
See you later.
Yeah, by the way, Nathan, to bring in another little puzzle piece, that same trigonometry system that he uses to measure the literal distance, supposedly, of the star, the Northern Pole star, you can use that same exact system on a flat Earth, and then all these objects all become a lot closer. That is how the circle-centrist flat earthers have come to the conclusion of the sun and the moon being at these literal distances.
Yeah,
and
but
all
what
that stuff. It's bending the model of the heavens from a globe back into a flat system. It becomes a lot closer, but it's still only angular relations. That's really the only thing you got. So you can bend it into whatever system you like.
Right.
Doesn't prove they're physical.
So guys, can I do a bit of a presentation if you've got a minute to listen to me?
We've got 3 minutes left, so yeah, Ranty, go ahead.
Oh, right. I'll really rush this then. I've basically triangulated my position using the sandcastle here.
Hold on. I need to share your screen, Ranty. Just give me a second.
Oh, right. Okay, sorry. Let me know when I'm presenting.
Isn't Ruhif a really great guest compared to the people like the Rumpus and Paul Voigt?
Oh, yeah. He's awesome.
Yeah, he's a good guy. Right, you're up, Ranty.
Say when. Right, okay.
He actually comes on with his face.
Here we have the sandcastle.
Cool.
We've literally got a couple of minutes left, so try not to interrupt him.
Right. So we have 3 buildings on the pier. So the sandcastle intersects building between 1 and 2, and then we've got the seawall here, which is directly under this building. And also I've put some lines in from the end of the pier, the ice blast, and this right-hand corner of the big one. So basically, through using all these different things and everything, I can get an exact location, which is here. So there's 6 points of reference that I can use to get this point. Also, I've got an image up that I want to show you for Blackpool of the pier. So this is the pier. And there's somebody walking along the beach. So you can see how tall this side of this structure is. And lastly, I'm going to put it out there that if I'm looking at this correctly on the video, let me just get it to the point. And we see these mountains, and it's halfway up. If we're going to say that pier is roughly, say, 30-35 feet, does that mean that for every mile or so that I travel from here, it should rise 15 feet? Because if I put a line in from a measurement from there to the pier, it's just under a mile. It's 0.95 of a mile. So if that's 44 miles away there, that means that the actual climb should be around about 700 feet, which is, funnily enough, exactly the height of the mountains that are 44 miles away. That makes sense?
Yeah, that makes sense. Anything you want to add?
If for every mile I'm travelling...
Did you want to add something, Mark? Sorry.
You use trigonometry. Oh, that doesn't work. I'm just being sarcastic. Yeah, I get what you're saying, Ranty.
I wish I had longer to get that point across, because I think it makes absolutely... Every mile that I'm travelling, my eyesight's travelling up another 15 feet, and by the time that I've travelled 43, 44 miles, it's around 700 feet. And when you go to 44 miles, you see that the mountains there are 700 feet, 770 feet. So it's consistent with what we're seeing on a flat plane.
Very good.
And I'm hoping he comes back with us with why it's not Puffin Island, because I'm dying to see that.
Cool. With that, I'm going to say first and foremost a huge, massive, enormous thank you to all of the debating panel for making this debate possible, and also a massive thank you to all of the live audience for tuning in and hopefully sharing this debate. If you've not done so already, be sure to like, comment, share and subscribe. I've been Nathan Oakley, and I will see you all in the next video.